is sinusoidal steady state analysis, starting lecture 8 with respect to chapter. In the previous session, I discussed about the observations from AC analysis of parallel circuit, that is RL, RC, and RLC circuit. I already solved two problems. Continuation of that, we have to see one more problem. Find ammeter reading when voltmeter reading is equal to 30 volts. All of you try it. Yes, friends. So what is the solution for this problem? Concentrate. Let the source voltage is Vs. We don't know about the source voltage. We have to find ammeter reading. To find the ammeter reading, find the current I. Then this I equal to I1 plus I2. It is not a arithmetic sum, it is a vector sum. If you have to calculate magnitude of I, this I equal to square root, that is I1 square plus I2 square plus 2I1 I2 according to parallelogram law, cos of angle between I1 and I2. That you have to calculate. Then how to write I1 friends? This I1 equal to, these are parallel branches. Let the voltage is Vs here. Vs by 3 plus J3. This is equal to Vs by, I'm finding the magnitude. This is 3 square plus 3 square into at angle of tan inverse 3 by 3. Angle of tan inverse 3 by 3. So correct. This is equal to Vs by, this is 9 plus 9, 18. That you have to write 3 root 2. This magnitude I am writing 3 root 2 at angle of 45. Tan inverse 3 by 3, tan inverse 1, tan inverse 1, 45 degrees. That is 3 Vs by 3 root 2 at angle of 45 degrees. At angle of minus 45 degrees. I am bringing into the numerator, na? That is minus 45 degrees. So this is I. Therefore, I calculated I1 equal to Vs by 3 root 2 at angle of minus 40. Next. But I don't know what the value of Vs by 3 root 2. When I know the value of Vs value, when I know the Vs value, then only I will find the I1. But Vs is not given. Then go for I2 calculations. What is I2 you have to write? I2 equal to Vs by 3 minus J3. That is to the same simplification, square root 3 square plus 3 square at angle of tan inverse minus 3 by 3. To simplify this, Vs by root 18, I am writing 2 root 3 at angle of minus 45. What is I2 equal to? Vs by 3 root 2, no? 3 root 2. This is 3 root. 3 root 2 at angle of 45. This is I. But here one condition, here it is given on data. Find the ammeter reading when voltmeter reading is equal to 30 volts. If voltmeter reading is 30 volts, what is the voltage across 3 ohm resistor is a 30 volts. Then what is the current here? 30 by 3. This is equal to 10 amperes. This is 10 ampere. This is 10 ampere means I2 also 10 ampere. Magnitude. That is 10 ampere. Neglect the current through the voltmeter. The current taken by the voltmeter is 0. Then this 10 amperes means I2 also 10 amperes. Therefore, what is the I2 friends? This I2 equal to 10 ampere. Then you have to write here. How I am getting this I2? This is 30 by 3, 10 amperes. Then I2 is 10 ampere. Vs by 3 root 2 at angle of 45 degrees. Angle of 45 degrees. That is I2 equal to 10 amperes. Here I2 is nothing but it's a magnitude, not the total. This is not the I2. You have to equate what is this I2 equal to 10 ampere. This is the magnitude. That is magnitude of I2 equal to 10 ampere. What is the magnitude of I2 here? Vs by 3. That is Vs by 3 root 2 equal to 10. If Vs by 3 root 2 is 10 ampere, now you have to calculate what is I1. I1 equal, substitute this Vs by 3 root 2 is 10 ampere. 10 at angle of minus 45. What is I2? This I2. Substitute Vs by 3 root 2 is 10 ampere here. This I2 equal to 10 angle of 45. So I1 is 10 at angle of minus 45, I2 equal to 10 at angle of 45 degrees. Then what is the angle between I1 and I2? Let this is the reference. This is 10 at angle of minus 45. Then clockwise angle, this is minus 45 degrees. And this is which value? This is I1 equal to. Students, it's very simple. Whatever the 10 ampere we calculated, that 10 ampere is the magnitude. What the magnitude of current? Vs by 3 root 2. That is 10 ampere. This I am substituting here. I got I2 is 10 at. Same Vs by 3 root 2 substitute here. Minus 40. This is I1. What is I2? 10 at angle of 45 degrees. 10 at angle of 45 degrees. Plus 45 degrees anti-clockwise direction. Then what the angle between I1 and I2? It is a 90 degrees. Angle between I1. Now I am calculating I equal to square root. That is I1 square plus I2 square plus 2 I1 I2 students. Cos of angle between I1 and I2. That is cos of angle between I1 and I2. Now I substitute here. What is I1 square? Magnitude of I1? 10. That is 10 square plus 10 square plus. But what the angle between this is 10 into 10. Cos of angle between I1 and I2 90 degrees. Cos 90 is 0. That is root 10 square plus 10 square. This is root 100 squares. So root 200 now. I'll simply take the 10 square is common. 10 square root 1 plus 1. That equal to 10 root 2. Then what is I you got? I equal to 10 root 2. Like this you have to proceed. Anybody solve this question? Should I given this homework for you? If you are not done this problem, then you have to concentrate. I am solving the problem. This I equal to 10 root 2. That is, instead of giving V as this data they given, using this data, I calculated magnitude of I2. This I am substituted here. Then I am getting the I2 value and the I1 value. Once you know the angles between I1 and I2, then apply the parallelogram law, then I am calculating the I1. I got this 10 root 2. Next. Can you try this? Find voltage across AB terminals of a circuit shown in figure. Are you tried this problem? Any answer? What the answer you got, friends? Find the voltage across AB terminals of the circuit shown in figure. You have to find what is the voltage across the AB terminals. Then VAB equal to, this is the AB terminals. These are the given AB terminals. This is A and this is B. Find the voltage across the AB terminals. This is given in the problem. This is A, this is. Let this point is C. Let this point is C. Shall I write like the VAB equal to, how you can write? If you have to find VAB, then VAC plus VC. I'm writing VAC plus VC. This VAC plus VC. Plus VC. Yes. To find VAB, we have to find VAC and VC. To find VAC, I have to find I value. Then how to find I value? To calculate I value, this current is given 1 ampere. Then apply current division rule. Rule for 30 minus J40. You have to apply current division rule for 30 minus J40. Across that, you apply the current division. Then what is this current, friends? This 1 ampere current equal to current division rule na total current into, if you want this current, total current into, let this is the total. Opposite impedance 30 plus J40. That is total current into opposite impedance by total impedance. That is 30 plus J40 plus 30 minus J40. Correct? 30 plus J40 plus 30 minus J40. Then plus J40 minus J40 cancel. Then 1 equal to I into, yes, friends. This 30 plus J40 by 30 plus 30, 60. Correct? 30 plus 30, 60. Then from this, what is I equal to? From this, what is I equals to? 60 by 30 plus J40. Then 60 by square root 30 square plus 40 square at angle of tan inverse 40 by 30. We have to simplify this one. We can get I equal to, by simplifying this, I equal to friends, 1.2 at angle of minus 53.1. I equal to 1.2 at angle of minus 53. This is the angle. Then what is the calculation of VAB? VAB equal to VAC into VCB. Na? Then VAB equal to VAC. What is VAC, friends? I into 5. That I into 5 plus. What is VCB? How to find VCB? This is 1 ampere. Na? 1 into 30 minus J40. This is VCB. 1 into 30 minus. This is C and this is B. VCB 1 ampere into this impedance. Then VAB equal to, what is I calculated? 1.2 at angle of minus 53.13 into 5 plus 30 minus J. Then VAB equal to 6 at angle of minus 53.13 plus 30 minus J5. You have to simplify this. Then by simplifying this, finally you can get, you have to simplify this. This also you can get 6 at angle of, better to write this one in terms of magnitude and angle. This 53 point, this is 50 at angle of minus 53.1. And what is VAB, students? Take the minus 53.13 is the common. 6 plus 50 at angle of minus 53. Then what is VAB? 56 at angle of minus 53. That is 56 at angle of minus 50. Like this you have. Clear, students? Any doubt? It's very simple. I have to calculate VAB. I'm writing VAB equal to VAC plus VCB. To find VAC, I have to know the current. Using this data, I calculate the current. Then you have to find the VCB. To find the VCB, I have to know, first I have to know this current. I apply the current division rule, calculated I value. Then these two drops is equal to V. One, that is 56 at angle of minus 53. Can you try this? In the following circuit, if A1 equal to 8 amperes, A equal to 10 amperes, the total circuit power factors, fraction of minute you can answer this. It's a parallel RL circuit. Can anybody answer this? Parallel RL circuit. What is the formula for power factor? What is the formula for power factor? Power factor cos theta equal to, in a parallel RL circuit, IR by I. Power factor is IR by I. A is the 10 amperes. A1 is the 8 amperes. This is I. What is current? IR. What is current? Yes. What is IR? 8 amperes. What is I? 10 amperes. 0.8. The power factor equal to 0.8 lagging. That is option A is the right answer. Simple question. A1 is the I value. A2 is the A2 is IL, but no need to find A2 because A1 is the IR. That is the current in the resistance. I is the, that is the total current. Is we are getting 0.8. Clear, friends? Can anybody answer this? For the circuit shown in figure, if A1 equals 6 amperes, A2 equals 16 amperes, A3 equals 8 amperes, the supply power factor is. This is the question based on the parallel RLC circuit. I'm expecting answer from you. Love it, right? Just a minute. Eh, Any answer? Nobody responding. Okay. Let this current is IR. This current is IC. This current is IL. Simple question now. This current is I squares. Yes, A1 is IR. IR is how much it is given? 6 amperes. A2 is IC. IC is given how much, friends? That is 16 amperes. A3 is IL. IL equal to how much it is given? 8 amperes. We know this I equal to square root. Here IC greater than IL. Na? IR square plus IC minus IL whole square. This is equal to square root. What is IR? 6 square plus IC minus IL. That is 16 minus 8 whole square. This is equal to 36 plus. This is how much? 64. No? 60. That is root 100. That is 10 amp. But what is the power factor? Power factor equal to cos theta. Cos theta always IR by I. IR is how much? 6 ampere. I is 10. That is 0.6. IC greater than IL. Here IC greater than IL squares. Then IC greater than IL, 0.6 lagging or leading. 0.6 leading. Capacitive nature is great. Then you have to take the 0.6 lead. Clear? Yeah, these are the different models of questions with respect to parallel circuit. This I'm giving for homework for you, practice. And this also homework for practice. Try it. And this also homework for practice. Try this one, sir. If you have any doubts, please share your doubts in my Telegram channel. This also homework. One more concept with respect to AC circuits is power calculations in single phase AC circuits. Today, this concept I will complete. Based on this concept, I will solve some questions. After tomorrow session, with respect to chapter 2, that is steady state AC analysis, mainly for AC analysis, I will solve gate questions. Gate EC and gate electrical, and we will try to solve the gate instrumentation. Then after that, we will start results. Yes. The concept is power calculations. Yes. The power calculation in resistance, inductance, capacitance, RL circuit, RC circuit, RLC circuit. For all these power calculations, power calculations, refer power triangles in previous explanation. Power triangles. For every circuit, I given the power triangles in previous explanation. In resistance, how to calculate the power. In inductance, what is the power. In capacitance, what is the power. All these I will explain. So please refer them in previous explanation. Okay. But for resistor, inductor, and capacitor, like this. But here I have to discuss in single phase AC circuit, 3 different cases I have to discuss. Before that, we know that in single phase AC circuits, power calculation is also very important. Already in GATE exam, the questions are framed. We'll see in tomorrow session what the questions are framed, how to solve those questions also. To solve that type of questions, whatever the concept I'm explaining, that is. In single phase AC circuit, how to write instantaneous power source? The instantaneous power equal to the instantaneous power. That is P of t equal to V of t into I of t. P of t into I of t. This is instantaneous power. Then how to write the average power? The average power that is equal to active power. Active power is also equal to real power. Once you know the instantaneous power, to find the average power, we have to integrate 1 by 2 pi integral 0 to 2 pi. That is P of t d omega t. What is P of t? 1 by 2 pi integral 0 to 2 pi. This is P of t into I of t d omega. Okay, this is the average power or active power or real power calculation. Okay. We know that in single phase AC circuit, the active power P equal to VI cos pi. And V is the RMS value. I is also RMS value. But this VI cos pi is average value. VI cos pi is average. Now see three different cases of calculation of power in AC circuits. This case one I'm explaining. For example, if V of t equal to, that is Vm sin omega t, Vm sin omega. I of t equal to Vm sin omega t plus or minus pi. It may be pi is given or theta is given, same calculation how to. This may be pi or theta source. This is power factor angle. That is, if V of t equal to Vm sin omega t, I of t equal to Im sin omega t plus or minus pi. There is no any multiples of frequency. There is no any harmonic component. Then in this case, how to calculate active power? Simply you can do like this. Active power equal to P equal to Vm by root 2. This is current now. Not I of t equal to Im sin omega t plus or minus. Im by root Vi cos pi na Im by root 2. Then cos of angle between voltage and current, that is cos pi. What is Vm by root 2? V. That is RMS value. What is Im by root 2? I. That is RMS value. Vi cos pi. Directly you can calculate like this. This is Vm sin omega t. This is even cos is given. You can apply same formula. This is active power calculation. Then how to calculate reactive power? This unit is watt. Then what the reactive power calculation in this case? Reactive. The reactive power Q equal to, that is Vm by root 2 into, that is Im by root 2 into sin pi. This is a reactive. That is Vi sin. Then the unit var, that is reactive volt amperes for reactive. That is a reactive. Next, how to calculate apparent power source? Apparent power. The apparent power S equal to, that is Vm by root 2 into Im by root. That is Vi. Then how to calculate power factor? Power factor equal to P by S. All of you well know this. Power factor equal to P by S. How to define complex power? The complex power equal to Vi conjugate. How to calculate the complex power equal to Vi conjugate. For RL circuit, what are the complex power students? P plus JQL. The power triangles I given. For RC circuit, the complex power equal to P minus JQC. Very good. This is case 1. If V of t equal to Vm sin omega t, I of t equal to Im sin omega t, some angle it is given. Then this is the calculation of active power, this is reactive power, this is apparent. Where Vi is the RMS values. V equal to Vm by root 2, I equal to Im by root 2. That is the RMS. Next. See the case 2 students. This is also important. Case 2 is, for example, sinusoidal supply to the linear loads. Sinusoidal supply to the linear loads. Sinusoidal supply to the linear loads. Supply to linear loads. We are giving the sinusoidal supply to linear loads. This example is network theory. Most of the loads we are taking the linear loads, not non-linear loads. It is a network theory concept. You know this one. Linear loads. What is V of t equal to? Vm1 sine omega t. Let assume that V of t equal to Vm1 sine omega t plus theta. I of t equal to Im1 sine omega t. Let this is alpha 1 sine omega t plus alpha. Then how to calculate active power? This see the difference here. This Vm sine omega t, but here Vm sine omega. Sinusoidal supply to linear load cycle. Then active power P equal to same calculation only. That is Vm by root 2 into Im by root 2. But cos of angle between voltage and current is theta 1 minus alpha. How to calculate reactive power, friends? If two different angles are given, how to calculate here? Reactive power Q equal to Vm by root 2 into Im1 by root 2. That is Vm1 by root 2, Im1 by root 2. Vm1 by root 2, Im1 by root 2. Reactive power na sin theta 1 minus alpha. How to calculate apparent power? How to calculate apparent power? Apparent power. The apparent power equal to Vm1 by root 2 into Im1 by root 2. Vm1 by root 2 into Im. Then what is the power factor? Once you know P calculation, Q calculation, and S calculation, then power factor equal to P by S. Like this. Clear, friends? This is case. See the one more case. I have to discuss total 4 cases. Case 3. Case 3. Non-sinusoidal supply to linear loads. Non-sinusoidal supply. Non-sinusoidal supply to linear. Supply is non-sinusoidal. It is given to the linear load. Non-sinusoidal supply to linear. If non-sinusoidal supply is given to linear load, mainly this is used in signals and systems. We know that in signals and systems we are giving is not a sinusoidal always, it is a non-sinusoidal. We can give the square wave or triangular wave like that. But load is linear load. Then in this case, because of non-sinusoidal supply, voltage is non-sinusoidal means current is also non-sinusoidal. Understand? Even though load is linear, sir, because of supply is non-sinusoidal, current is also non-sinusoidal. Then for example, V of t equal to V naught plus Vm1 sine omega t plus phi 1 plus Vm2, different models I am giving, sine 2 omega t plus phi 2 plus and so on. Current is also non-sinusoidal. I naught plus Im1 sine omega t plus alpha 1 plus Im2 sine omega t plus alpha 2 sine 2 omega t plus alpha plus and so on. Then for this case, what is the active power source? Then active power P equal to, simply calculate like this, V naught into I naught plus these constant terms directly multiply, that is the DC terms. Then Vm1 by root 2 into Im1 by root 2 into cos theta 1 minus alpha 1 plus Vm2 by root 2 into Im2 by root 2 into cos theta 2 minus alpha 2, theta 2 or pi 1. So taken this is theta 1. Just think. Taken this is theta 1, this is theta 2. So pi 1, pi 2, I am taking theta 1 there. Cos of theta 2 minus alpha 2 plus also. What the reactive power? Then you have to calculate reactive power as Q equal to reactive power. Q equal, that is V naught into I naught plus, that is Vm1 by root 2 into Im1 by root 2 into sine theta 1 minus alpha. Vm2 by root 2, Im2 by root 2 into, that is sine theta 2 minus alpha. Then how to calculate apparent power? This is important. Apparent power. S equal to Vrms into IRMS. Then how to calculate Vrms? This is Vrms square root. For this type of voltage or current, how to calculate RMS value? I already given. V naught square plus Vm1 by root 2 whole square plus the multiples of frequency na Vm2 by root 2 whole square plus and so on. What is IRMS, friends? Try to calculate what is IRMS. Then IRMS equal to square root. This is Im1 by, that is I naught square plus This is I naught square plus Im1 by root 2 whole square plus Im2 by root 2 whole square plus and so on. Once you know the VRMS and IRMS, this is the apparent. See the difference here. Here we got the apparent power directly Vm1 by root 2, Im1 by root 2. But here harmonic components, multiples of frequencies there. Calculate VRMS, IRMS separately. Once you know the apparent power and active power, power factor equal to P by S. These are the calculations. Non-sinusoidal. If the non-sinusoidal supply is given to linear loads, current is also non-sinusoidal because supply is non-sinusoidal. That is in signals and systems. And one more example is, you take one more model here, case 4 that I am giving. Sinusoidal supply to non-linear load source. Sinusoidal supply to non-linear. Sinusoidal supply to non-linear loads. Non-linear loads. Where you can use this? For example, if you take the any one rectifier, this is the load, any load you take. Now I am giving the sinusoidal supply. This, even though supply is sinusoidal, once the current is enter into the sorry, it is disconnected. Yes. Students, is it visible now? Please, anybody respond? Thank you. Harmonic. That is, even though supply is sinusoidal, when the current is enter into this circuit, it becomes a harmonic current. Sinusoidal supply to non-linear loads. These are the non-linear. Then this is used in power electronics. This is used in power electronics. Sinusoidal supply to non-linear loads. This is used in power electronics. So, for example, V equal to Vm sin omega. V equal to Vm sin omega. Let some angle theta. Then what the current? The current I of t equal to, it may be consist of DC component also. Im1 sin omega t plus alpha 1 plus Im2 sin 2 omega t plus alpha 2 plus and so on. This is because of nonlinear loads, it consists of the, even though supply is pure sinusoidal, but current is non-sinusoidal. Why? Because of nonlinear. But see this one, friends. Non-sinusoidal supply to linear loads. Even though load is linear, because of supply is consist of harmonics, current is also harmonics. Even though supply is sinusoidal, because of nonlinear loads, current is harmonic. Current is harmonic. Now for this case, then how to find the, that is active power? P equal to, very important observation, sir. Listen. Here there is no any DC term, but even though it consists of DC term, here there is no DC term. That's why we don't get that. In power calculation, we don't get the time because here there is no DC term. And in this case, you always multiply with equal frequency terms only. Equal frequency terms. This we can get Vm1 by root 2. That is Vm by root 2. Let this is the Vm1 source. Vm1 by root 2. Im1 by root 2 cos theta 1 minus alpha 1. Remaining terms you don't get because this is only which component? Fundamental. Only fundamental. This only. But even though sin 2 omega t is there, but here sin 2 omega is not present. Sir, how you can get this formula, sir? You multiply these two, integrate and substitute the limits. Finally, you can get remaining terms becomes 0. Then what is Q? You tell me. Vm1 by root 2, Im1 by root 2. The power is due to only fundamental component here. Sin theta 1 minus alpha. What is S equal to? VRMS into IRMS. Then how to calculate VRMS, friends? Only one term is there now, Vm1 by root. How to calculate IRMS? Square root. How to calculate I naught square plus Im1 by root 2 whole square plus Im2 by root 2 whole square plus and so on. This is the calculation of. Once you know this VRMS and IRMS, then you can calculate apparent power. Then what is the power factor? Power factor equal to E by S. Clear, students? But observation is important here. You have to multiply only equal frequency terms. But this is 2 omega, but this side 2 omega t is not there. Then that becomes 0. But point to remember, these functions, sine is given, even cos product will come. This formula is applicable. Even sine case it is applicable, even cos is given also it is applicable. If sine product is came or even cos product is came, you take the cos only in active power calculation. But in reactive power calculation, always it is a sine. So that clear? These are the power calculations in different cases. In this case, this model is important even in power electronics point of view, electrical students. Clear? Already, even GATE 2022 also based on this question is electrical, 2 mass model. You have to multiply only with equal frequency term. Equal frequency term. This about the power calculations in a AC circuit. With this knowledge, we'll see some questions. Can anybody answer this question? A 220 volts 50 hertz supply is applied to a series RC circuit. The current flowing is 2.2 amperes and the power dissipated is 242 watt. The value of R and C are respective. Right? A 220 volts 50 hertz supply is applied to a series RC circuit. The current flowing is 2.2 amperes and the power dissipated is 242 watt. Then you find the values of R and C. From one condition, we can easily calculate R values. The power dissipated P equal to I square R. From this R equal to P by I square. But the power is given 242 watt. The current is 2.2 amps, 2.2 square. Then how much resistance we can get? Anybody? Think you can get nearly equal to 50 volts. R equal to 50 volts. Then A is not the answer, C is not the answer, either B or D is the answer. Then shall I apply like this? I equal to V by RC circuit now, R square plus XC square. I equal to V by square root R square plus XC square. This is in RC circuit. What is I? It is given 2.2 amps. V is 220 volts. Square root R square. R square is how much? That is 50 square plus XC square. From this we calculate the XC square. Then square root 50 square plus XC square equal to 220 by 2. This is equal to 100. Yes, friends. 50 square plus XC square equal to 100 square. Square on both sides. Then XC square equal to 100 square minus 50 square. This is equal to how much you get? This XC equal to square root 100 square minus 50 square. Calculate this value. Square root 100 square minus 50 square. We are getting 86.6 volts. This is XC calculation. If you get the XC equal to 86.6 ohms, then what is XC equal to, friends? 1 by 2 pi FC. From this, what is C equal to? 1 by 2 pi F into 86.6. 1 by 2 pi, frequency how much? 50 hertz, 86.6. Then how much capacitance you get? 1 by 2 pi into 50 into 1 by 2 pi into 50 into 86.6. This approximately how much you got? Can anybody? Using this, I calculated R value. Using this, you calculated the C value. I'm getting a 36.7 microfarad. 36.7 microfarad. That is 50 ohms, 36.7 microfarad. That is approximately B is the answer. B is the answer. Clear? Okay. Next. This RL circuit now. If it is RC circuit, it is RC circuit. This is R, this is C. Then how to write the I equal to this is V. I equal to V by square root R square plus XC square. That I did. If it is RL circuit, and this is the V, That this is I, students. This is R, this is L. How to write I equal to V by square root R square plus XL. Yes, sir. A RLC series network with R equal to 100 ohms, L equal to 125 millihenry, C equal to 15 microfarad, 50 micro, is subject to a sinusoidal voltage with a maximum amplitude of 200 ohms and a frequency of 800 per second. The average power supplied by the source is, you have to calculate the how much average power supplied by the source. Any answer? Yes, friends. You have to calculate what is the average power supplied by the source. Average power is nothing but active power. How to calculate the active power? P equal to VI cos. Then to calculate this P, that is V, I'm writing Vm by root 2. Then you can also write Im by root 2 into cos. But I don't know what is the power factor. I don't know. But I know the voltage. RMS voltage I know. So maximum amplitude I know. What is Vm? It is given 200. Now you have to calculate Im. To calculate Im, it is RLC circuit. How to calculate Im, friends? This Im is calculated as Vm by Z. Vm by Z. That is, you have to apply Vm by square root R square plus XL minus XC whole square or XC minus XL whole square. Because the square term, XL minus XC you apply or XC minus XL you can get positive one. Then how to calculate XL? XL equal to omega. Omega, that is angular frequency is given 800 radian per second. The inductance is given 125 millihenry. It is 125 into 10 power max. Simplify this, friends. How much we can get XL? This XL equal to, you can get 100 volts by simplifying this. Calculate XC. XC equal to 1 by omega C. XC equal to 1 by omega C. 1 by omega. Omega is 800 radian per second. How much capacitance? 50 microfarad. Please simplify this. How much XC you got? This XC you can get nearly equal to, it is a 25 ohms. It's a 25 ohms. Clear? Then you have to find the R value. Is it R is given? Yes, R is given. No need to calculate. R equal to 100 ohms. Now substitute all the values. Then Im equal to Vm. Vm is maximum amplitude now 200. 200 by this R plus J into, which is greater here? XL greater than XC. XL, because I want the angle also. To find the power factor, sorry, to find the power, you have to calculate the angle also. That's why instead of writing magnitude, I'm writing in with imaginary term also. Because XL greater than XC, you have to take XL minus XC. That is 200 by R is 100 plus J into XL. XL is how much? If you calculate magnitude and angle separately also, that is no problem. You calculate magnitude and angle separate. If you want to do that directly, I'm writing like this. Directly calculate magnitude first, friends. Square root R square 100 square plus XL minus XC. XL is 100, XC is 25. So the magnitude and angle separately. This we got 200 by square root 100 square plus 100 minus 25 whole square. Is approximately we can get a 1.6 amps. It's correct, 1.6 amps. Then what is the angle? Pi equal to tan inverse XL minus XC by R. XC minus XL minus XC by R. Then tan inverse, what is XL? XL is that is 100 minus 25 by the resistance is 100. That is tan inverse is approximately equal to 75.75. Tan inverse 0.75. How much you can get? Approximately it is a 36.86. Then what is the power? What is the power? P equal to VI. Vm by root 2. No? Vm is 200. 200 by root. What is Im? 1.6 by root. What is the angle? Angle it is 36.86. How do these calculations, friends? Approximately we can get 128 watt. This is correct. We check it. 200 by root 2, 1.6 by root 2. That is cos of 36.86. This is equal to 128 watts here. This is the calculation. Just by seeing the problem, first you have to write down the formula. Then after writing the formula, then you get an idea which parameters you have to calculate to get the answer. Once you know which parameters you have to calculate, then you know the formulas, apply the formulas, then you can easily get the answer. First read the question, write down the parameters, write down the formula, then you have to see which parameters are required to solve this problem. Next. In the given circuit, the complex power delivered by the voltage source S equal to 14.4 plus J 28.8 volt ampere. The values of R and L is. You have to calculate the values of R and L. Can you try this? This I am leaving for you. Check it. This is homework for practice. See the one more question. The voltage applied to the circuit shown in figure is Ps of t equal to 12 root 5 cos 40 volts. The complex power delivered by the. For this question, answer is option D, students. Answer is option D. That is what right. The voltage applied to the circuit shown in figure is 12 root 5 cos 40 volts. The complex power delivered by the sources. What is the complex power delivered by the source? That is how to calculate. Yes. How to calculate complex power? Told already. S equal to Vi conjugate. Shall I write like this? That is Vm by root 2 into Im by root 2 conjugate. But you know, supply voltage 12 root 5. If supply voltage is 12 root 5, what is Vm, students? Vm equal to 12 root 5 volts. Then how to calculate Im equal to? Im equal to Vm by Z. Yes. What is omega here? This is cos 14, omega equal to 4 radian per second. Yes. This you have to calculate J omega L. Inductive reactance na XL equal, that is JXL. I am calculating J omega L. Omega is 4 radian per second, inductance is 2, that is J8. I have to calculate equivalent impedance here. The equivalent impedance equal to this J8 in parallel with 8. That is 8 in parallel with J8 plus 4. Clear? Then you calculate what the Z equivalent, that is Z equal to. That is 4 plus 8 into J8 by 8 plus J8. Take 8 is common, then 4 plus, if 8 is common, 8 cancel, J8 by 1 plus J1. Then you simplify this, what you can get, friends? That is 4 plus J4 plus J8 by 1 plus J1. Correct? Then what the Z equivalent we are getting? That Z equivalent, that is Z equal to 4 plus J12. 4 plus J12 by 1 plus J1. 4 plus J12 by 1 plus J1. Correct? Then multiply with the complex conjugate. 1 minus J1 by 1 minus J1. I'm simplifying this one, sir. This, if we simplify this, what is the Z equivalent we can get? The Z equivalent, that is Z equal to 4 minus J4 plus J12 minus J into J, J square minus 1 minus into minus plus 1 by 1 plus J1, 1 minus J1. 1 square plus 1 square, that is 2. 16, 16, this is minus J4 now. This is minus J4. This plus J12, that is J8 by 2. 8 plus J4 we get. Z equivalent equal to 8 plus J4. If Z equivalent equal to 8 plus J4, then you have to calculate what is Im. Im equal to, that is what is Vm? That is 12 root 5 by 12 root 5 by 8 plus J4. 8 plus J4. Let's do the calculation. Then you do this calculation, friends. S equal to Vi conjugate now. Vm is how much? 12 root 5 by root 2 into Im is 12 root 5 by 8 plus J4 whole conjugate. If we simplify this, I'm leaving for you. This we can get 36 plus J18 volt. 36 plus J18 volt. That is how to do this calculation. All these are mathematical calculation. This I got Z equivalent equal to 8 plus J4. Is it correct? So that is 4 plus J12 by 1 plus J1. This is the Z equivalent. Is correct. J4. This is 4 minus J4 plus J12 plus 12. 20 plus J. This is 20. 16. 16 plus J, correct. Then 8 plus J4 is correct. That I am substituting here Vm, that is Im equal to Vm by Z. 12 root 5 by 8 plus J4 whole conjugate. This is whole conjugate. Then you take this is 8 minus J4. If it is a conjugate now, 8 minus J4. Then you have to simplify. 8 plus J4 conjugate is 8 minus J4. Then you simplify this, we can get 36 plus J 18 volt amperes. Next. Can anybody answer this? The average power and reactive power absorbed by the circuit respectively. This is theta 1 and theta 2. Two different angles are given. Theta 1 and pi 1. Theta 1 and alpha. How we can solve? What is the formula for active power? Vm by root 2. Im by root 2 cos of theta minus alpha. Vm is 112. 112 by root 2. Im is 8. 8 by root 2 cos theta minus alpha. Theta is the angle given for voltage. 20. Alpha is the angle given for current. Minus of minus 40. This is 112 by root 2 into 8 by root 2 cos 60 1 by 2 squares. Root 2 root 2 2 2 into 2 4 4 8 by 4 2 112 into 2 224 watt. 224. You have to find the reactive power also. No? Reactive power equal to Vm by root 2 into Im by root 2 into sin theta minus alpha. What is Vm, sir? Vm is 112. It is 112 by root. What is Im? 8. 8 by root 2 sin 60. 20 minus half minus 40 sin 60. Sin 60 equal to root 3 by 2. Yeah, this is how much you can get. Come on. I think 224 root 3. Where? 224 root 3. If we simplify this, we can get 388 watt reactive volt amperes. That is option A is the right answer. Option A is right answer. And one more question. This I am giving homework for practice. If you have any doubts, and if you are not getting the answer, please share your doubts in my text. Here I am